Good morning, students. Today we will complete the chapter number 13, and there will be a discussion session after finishing this chapter. So be ready for the discussion. So we will start. Already it is 10:11. Seventeen students are joined. Some students are joining. Yes, we will start. So this is a very small chapter actually. This is having weightage 3 marks with option and 4 marks. So the organic chemistry part will be completed today. So most of the important chapters from organic chemistry, these are halogen derivatives, that is chapter number 10. Then chapter number 11 is alcohol, phenols and ethers. Then chapter number 12 is aldehyde ketones, carboxylic acids. And this is the last chapter of the organic chemistry, that is amines. So first time I taught this organic chemistry without board. So if our college will start, again we will do the revision of some important aspects of these organic chemistry, because some of Grignard reagent reactions, then how the lone pair attacks. So I will explain the mechanisms also: aldol condensation reaction, then SN1 reaction, SN2 reaction, and how the nylon 6 is prepared, nylon 6,6. So these are the very, very important questions. They are again and again asked for the board exams. So I think if the college will start after, I think, October, there are hopes to open the colleges, and up to the October, I think our syllabus will be completed. So we will take the revision in the month of November and December. So it will be very, you will get the very crucial time at that time. So if the syllabus is earlier completed and all the notes are already given to you, only we have to read these notes and prepare your own notes according to this. So as I am the member of the HSC board chemistry, everything I am giving to you. I want to give important hint to you. Whatever the exercise is given behind the chapter, so 100% it is not possible. Remember, in 10th standard, whatever the exercise is given, the examiner will ask the questions from the exercise. But now, according to this new syllabus, only 1 or 2 questions will be asked from the exercise. We have to read the entire chapter carefully, and then we will get the good marks. So this is a very important instruction to all. Not 100% question will be asked from the exercise. Daily we have to read the whatever the notes I am sending to you. We have to write your notes in your own words. Also practice the reactions. And if you have any problem, then call me. Same for CET and same for other competitive exams. It is not necessary to go for anywhere. If you want to learn about the more MCQs and more practice is required, then purchase new books. Then for students who are only preparing for the board exam, these notes are sufficient. If you want to prepare the CET exam, then Dinesh publication is a very nice book. Also Vidya Bharati Prakashan is very nice book. So we will discuss all these points after the finishing this chapter amines. We will open for the discussion. So I want to complete this chapter first. So yesterday we are discussing about this Hinsberg test. Student, remember this Hinsberg test. It is a test for identification of primary, secondary, and tertiary amines. So already you know about this, what is mean by primary amines, what is mean by secondary amines, and what is mean by tertiary amines, because this is now you are coming to the end of the chapter. So primary amines, I will just again explain you. Primary amines in which these are the derivatives of ammonia. All the amines are derivatives of ammonia, in which in case of primary amine, one hydrogen is replaced with one R group. In case of secondary amines, there are two hydrogens are replaced with two R groups, and in case of tertiary amines, all the three hydrogens are replaced with three R groups. So this is the classification, and this Hinsberg test is important to identify which is primary amine, which is secondary amine, which is tertiary amine. So for this Hinsberg test, Hinsberg reagent is used. See here, clearly I have mentioned it is purposefully it is kept in a square bracket. This is benzene sulfonyl chloride, remember. This benzene sulfonyl chloride having the formula C6H5Sa2Cl. Before this, you know about this sulfonyl chloride, SOCl2, thionyl chloride, but this is a benzene sulfonyl chloride. See, the structure is given here. This is a benzene, and this is the SO2 group, and this is chloride. So this benzene sulfonyl chloride is called as a Hinsberg reagent for the board exam. 1 mark question, this question may be asked, what is Hinsberg reagent, or write the formula of the Hinsberg reagent. So remember this one, you can write the formula also, or you can draw the structure also. So first, what is the reaction of primary amine with this benzene sulfonyl chloride? See, this is a benzene sulfonyl chloride, and this is a primary amine. We can take any primary amine which is having two hydrogen atoms are attached here, NH2. So this reaction takes place, this chlorine and this hydrogen, it is removed, and this ammonia molecules gets bonded to the sulfonyl group, and we get here N-ethyl benzene sulfonamide. So amines, these amines are converted into amides, and it is soluble in alkali, because I will explain why this is soluble in alkali. See carefully here, one hydrogen is attached to this nitrogen, because only one hydrogen and only one chlorine, this is removed, and these two molecules join together, and we get here amides. So I want to explain here, this one hydrogen which is attached to this nitrogen is very acidic. Acidic means this is very easily removed, because of there are two electron withdrawing groups. See, this is one carbonyl, this is another carbonyl. Because of these two electron withdrawing groups, this bond becomes weak. Nitrogen and hydrogen, this bond becomes weak, and this hydrogen is easily removed. That's why it is called as acidic. So if this is acidic, it is easily soluble in alkali. That's why this amide is soluble in alkali. So if the product soluble in alkali, we can identify it is a primary amine. So we will discuss what is happening in case of secondary amines. So here, see, we are using diethylamine here. Diethylamine is the secondary amine, reacts with benzene sulfonyl chloride to give N-diethyl benzene sulfonamide. We get here NN. Already I discussed what is this N means these two ethyl groups are attached to this nitrogen. That's why it is called as N-diethyl benzene sulfonamide is formed. See, in the previous reaction, there are two hydrogens are there, but in case of secondary amine, there is only one hydrogen. So this hydrogen and this chlorine, it will be removed, and we get there N-diethyl benzene sulfonamide. So The change between primary and secondary amine product is no any hydrogen is attached here. See, as there is no any hydrogen is attached, there is no question of acidity and basicity. If there is no any hydrogen, so there is no possibility of acidity. So this product is not soluble in alkali because this is not acidic. See, this one. N-dimethyl benzene sulfonamide is not acidic because no any hydrogen is there. As this is not acidic, this is not soluble in alkali. So we can easily identify this is secondary amine. Now in case of tertiary amine, you know, in case of tertiary amine, there is no any hydrogen is there. So the reaction will does not take place. Tertiary amine do not react with benzene sulfonyl chloride because there is no any hydrogen and there is no possibility of the formation of HCl. So this is a Hinsberg reagent or Hinsberg test is useful for the separation, for the identification of primary amines, secondary amines, and tertiary amines. How will you identify whether these are the primary amines? When the product is soluble in alkali, it is called as primary amines. When the product is not soluble in alkali, it is called as secondary amines. And if the reaction does not take place, it is the given amine will be tertiary amine. But this yellow colored purposefully I have given this box because this box is asked for the CET and for the NEET exam and for the JEE exam for 4 marks. Remember, this question is asked for 4 marks, but this is not given in your textbook. I have given because side by side I have to give the knowledge of CET also and for the JEE also and for the NEET also. So nowadays this benzene sulfonyl chloride means this Hinsberg reagent is replaced by para-toluene benzene sulfonyl chloride. That is para-toluene sulfonyl chloride. Means here toluene group is there. Para-toluene benzene sulfonyl chloride. One word is missing. Para-toluene benzene sulfonyl chloride actually. Means only CH3 group is attached here. See. If the CH3 group is attached, this is a new reagent, new Hinsberg reagent, and this is asked for the CET exam also and the NEET exam also. So I think you understand this Hinsberg reagent and Hinsberg test, identification of primary, secondary amine. Now I am coming to the next part. Actually, this is repeated many times in halogen derivatives also, electrophilic substitution reactions, in phenol also, in ethers also. So again and again, these electrophilic substitution reactions are repeated, and this is a last electrophilic substitution reaction because organic chemistry parts now it will ends. There are only four chapters of organic chemistry. Once again, I am repeating halogen derivatives. It is chapter number 10, alcohols, phenols, ethers, chapter number 11, then aldehyde, ketones, carboxylic acids. It is chapter number 12, and this is amines. Last organic chemistry will be completed here. So again, I am coming to the electrophilic aromatic substitution reactions in which electrophile is substituted. We are discussing about the electrophilic substitution reactions of these amines now. So you know these basic things. In electrophilic substitution reaction, the group attached to the benzene is very important. Whether this group attached to the benzene is ortho-para directing, we will get one is ortho and one is para. If this is a electron withdrawing group, we will get the meta product. So whatever the electrophilic substitution reactions we learn, that is chlorobenzene is also ortho-para directing, then phenol is also ortho-para directing, then anisole is also ortho-para directing. This aniline is also ortho-para directing. So this bromination reaction also we learned in this chapter, halogen derivatives also, reaction with bromine. There are two types of bromination reaction. One is bromination with bromine water and another is bromination with carbon disulfide, that is CS2. So this aniline is aromatic amine, reacts with bromine in bromine water. See, always when bromine water is used, we get this bromine at 3 position, 2, 4, 6. Always remember, when the bromination is done in presence of carbon disulfide, we get only ortho and para products. But only when the bromination or chlorination is carried out in bromine water or chlorine water, Same as chlorination can be carried out with chlorine water. Remember, this is thrice Br2. It is given. This is bromination. If instead of this thrice Br2, if thrice Cl2 is given, we will get here chlorine, chlorine, chlorine. 2,4,6 trichloroaniline. So such type of questions will be asked for the CET, not for the board exam. Board exam will give the same examples. But if the paper setter want to check your talent, then he can give here instead of bromine, they can give chlorine also. Remember. So at that time, don't discuss this question is out of syllabus or this is not included in your textbook. I think in chapter number 11, in alcohols, phenols, and ethers, it is mentioned. One sentence is purposefully mentioned there. Bromination with bromine water and chlorination with chlorine water gives the same type of products. So this aniline reacts with bromine water. We get this 2,4,6 tribromo aniline here. As this is amino is electron donating group. So if I want to prepare only one product here, see. First see this, then I will explain what is this is given, because this is very important, very important part. This is activating and deactivating. So I will explain first what is this, why this is necessary. If you want to prepare only parabromoaniline, then what we have to do? How to control the reactivity of this NH2? This aniline NH2 group is ortho-para directing group. Remember, means it gives one is ortho product and one is para product. But if you want only one product that is at para position, then what we have to do here? So it is written here. See, this can be done by protecting the NH2 group. Protecting the NH2 group means what? We have to do the reactivity of this NH2 group should be controlled first. NH2 group we have to deactivate first. As this NH2 group is activating, we get the ortho product and para product. But if you want to get this only one para product, what we have to do in first step? We have to do the we have to decrease the activity of this NH2 group. And how to decrease the activity? This process is called as protection. So protection is nothing but decreasing the activity of this NH2 group, and this is done by acetylation with acetic anhydride. So what we have to do in the first step, this NH2 treated with acetic anhydride, and we get this is intermediate first. So this intermediate is called as acetanilide, or it is also called as N-phenyl ethanamide. So why we are doing these steps? For getting only one product, this we have to do this protection, and again we have to do the deprotection. So after protection, we have to carry out the bromination reaction. So we will get only one here para product here, bromination, because at ortho position, as the steric hindrance is there, the bromine will be not attached here. So we will get here bromine as a major product, and again after hydrolysis, acidic hydrolysis, we get back the aniline here. So this is a protection and this is a deprotection. Protection is done with acetic anhydride and deprotection is done with hydrolysis with acid. So this is called as protection, deprotection of the aniline, and this is required to get only one product here. So if any student asks, sir, how this acetanilide is non-reactive than the aniline? So I will explain what is happening. This CO group is electron withdrawing group C. So the lone pair of this nitrogen, which is in case of aniline, this lone pair is available for the donation, and this lone pair, it is involved in the resonance. See, I will show here. See, in case of acetanilide, how the reactivity of this acetanilide is decreased, because the lone pair of nitrogen, it is involved in resonance. So it is not available for donation. That's why the activity of this acetanilide is decreased, and we get only one product. So the activating effect of this NHCO-CH3 group is less than the amino group, because of this resonance takes place there. So this is not asked for the exam actually, but for the understanding purpose I have shown here. because many students are very eager to know why this is deactivating and why NH2 is activating. So they will get the answer of this question. Now the same as nitration also, already the nitration reaction, it is completed for 2-3 times. We learn about the nitration of phenol also, then nitration of aniline, nitration of anisole also, then the nitration of chlorobenzene also. So this is, I think, fourth time we are studying about the nitration reaction. We know nitration means the introduction of NO2 group to the benzene ring. And this nitration is always carried out with a nitrating mixture. This is a mixture of concentrated HNO3 and mixture of concentrated H2SO4. But this nitration is quite different. We already discussed the different nitration reaction, but this nitration is different. Why? Because I will explain this. Ammonia NH2 is basic. This ammonia NH2 primary amine, that is when it is attached, see here, this NH2 is basic and this mixture is acidic. This HNO3 and mixture of H2SO4, this is acidic. So what will happen? This NH2 will pick up one hydrogen and it will be protonated, and the aniline ion is prepared. See, as this mixture is acidic, the mixture of concentrated HNO3 and the mixture of concentrated H2SO4 is highly acidic. So what is the this ammonia having the lone pair, it will pick up one proton and it becomes NH3 plus. And you know this NH3 plus is a meta directing group and deactivating group. So we get also the considerable amount of here meta product. See here, we can see here meta product is also 47% meta product is also formed, and this is formed due to this aniline ion. In case of nitration of phenol, in case of nitration of chlorobenzene, in case of nitration of anisole, we didn't get here meta product, but in this nitration of aniline, we get here meta product because of this aniline ion. So this nitration is quite different. Again, if you want to get the only one nitro product, again we have to do the protection and deprotection of this one, like bromine. In bromination, we already learned how to do the protection of this NH2 group. The protection is done by using this acetic anhydride. We get here acetanilide. Acetanilide then undergoes nitration. We get here NO2. We do not get here ortho product because steric hindrance is there. So we will get here only the para-nitroacetanilide, and deprotection is done by using hydrolysis. So the protection and deprotection, I think you understand what is meant by protection and what is meant by deprotection, what is nitration, and what is next reaction is sulfonation reaction. This reaction is also completed in the previous chapter. Sulfonation means introduction of the SO3H group. This is the sulfonic acid is formed. In this nitration, in this sulfonation reaction of aniline, see, it is react with concentrated H2SO4. We get here first intermediate. Why this intermediate is formed? Because this is more acidic. As this is acidic, we get this aniline hydrogen sulfate. It is a salt. This is one is acid and one is base. Say this aniline is base and we are adding acid. So the salt is prepared first. This is aniline hydrogen sulfate will be prepared first. This is a salt. And after heating this salt at the temperature 453 to 473 Kelvin, we get here aniline sulfonic acid. It is also called as sulfanilic acid. Remember, this may be asked for 1 mark. Draw the structure of sulfanilic acid. This may be asked for 1 mark, remember, in the question number 1. So remember this sulfanilic acid, NH2 and with SO3H group, it is also called as aniline sulfonic acid, or it is also called as para-aminobenzene sulfonic acid, and it is also called as sulfanilic acid. There are 3 different names of this product. So this product, one is a base and one is acid. So the zwitter ion is formed. What is meant by zwitter ion? I will explain. This sulfanilic acid this sulfonylic acid, or it is also called as para-amino benzene sulfonic acid, it is having two groups. One is a basic group and one is acidic group. When the acidic and basic groups are present in the same molecule, the Zwitter ion will be formed. Remember this Zwitter ion, it may be asked for 1 mark. What is mean by Zwitter ion? So the answer I'm telling you, the Zwitter ion means it is nothing but when the acidic group, this is acidic group, and when the basic group, this is a basic group, when both the groups are present in the same molecule, such type of compound is called as Zwitter ion. So this is a Zwitter ion. It one hydrogen can be shifted here. It gave plus and minus. So it is NH3 plus and SO3 minus. So such type of compound is called as Zwitter ion. And the most important question I have written here, aniline does not undergo Friedel-Crafts reaction. Explain for 2 marks. So for the board exam, this question may be asked, why aniline does not undergo Friedel-Crafts reactions? You know about the Friedel-Crafts alkylation and acylation reaction. We discuss in detail in 11th standard also, in 12th standard also. Many times we discuss these reactions. What is meant by Friedel-Crafts alkylation? That is, there are two reactions. Friedel-Crafts alkylation means alkyl halide is used, and in case of acetylation, acyl halides are used. So I'm not explaining the again and again details because many times these reactions are repeated. So this for the Friedel-Crafts reaction, you know, the catalyst AlCl3, that is aluminum trichloride, we have to use these reactions. Aluminum trichloride, this is used as a catalyst. And what is the role of this catalyst? This catalyst generates the electrophile. But in case of aniline, this NH2 group reacts with the catalyst aluminum trichloride, and one salt is formed, and that salt is a deactivating group. That's why the further reaction is not possible. So why this Friedel-Crafts reactions are not possible? Because of this aniline ammonia group, primary amine group NH2. This NH2 reacts with the catalyst aluminum trichloride, and we will get the one salt is formed, and that salt is a deactivating group. That's why further reactions are not possible. So that's why aniline does not undergo Friedel-Crafts reactions. So this chapter is completed here. Then I will open the lecture for the discussion. I will mute all now. Unmute all, sorry. Yes, now you can unmute yourself. Unmute हो रहा है? Wait. Yes, all students, check your mics. नहीं हो रहा है unmute. Write in the chat box. Yes. Yes, हो रहा है ना unmute?
Yes, sir.
So I want to discuss some things with you because I do not give chance to unmute yourself because we have to complete the entire syllabus before October. And for you, I have prepared this all the PPTs. This takes more time actually. So I think you are doing the preparation at your home. It is very difficult task to teach the organic chemistry online, remember. It is very difficult task without the board, blackboard or whiteboard. With the mechanism, it is a very highly impossible to explain, but I tried my 100% best to explain the organic chemistry with the help of these slides. So after the college will reopen again, I will discuss some of the reactions on the board also. So this session is open for you. You can discuss your problems with me. Which type of difficulties you are facing, you are purchased your practical books or not, you started the writing the activities or not, tell me. Yes, Arjun is there, Sonia is there, many students are there, participants. I will give, yes, Sahil Riker is also there. Riker, unmute yourself and talk. Kedar Jadhav is there. Hitesh Sutar is there. Hitesh. Yes, Hitesh is there. Hitesh, yes, tell me. Apurti, unmute yourself and tell me, you purchased the practical notebook and you started writing the activities or not. I have given one activity to complete from the chapter that is green chemistry. So we have to purchase the practical books also, and we have to start writing the activities. I have given one activity to complete. Again tomorrow, tomorrow there is no lecture. On Friday I will give the second activity which we can complete at your home. So side by side we have to do our practical work also, because we have to complete the 60% practical work. Remember, if the 60% practical work is not completed, then it is very difficult to appear for the board exam. So activities also we have to complete. All the students purchase the handbook and handbook cum journal. Yes, mute yourself and tell me how many students purchase this handbook cum journal, or no any student purchased. Discuss with me. Apurti?
No, sir.
So within these 2 days, we have to purchase the practical cum journal and write the activities first. So whatever the questions we have regarding the organic chemistry or physical chemistry, tomorrow we will start, day after tomorrow we will start the chapter number 8. Sorry, chapter number 9, that is coordination chemistry. The chapter's weightage is very high. 7 marks weightage is there. Last year's weightage was only 4 marks. This year I purposefully increased the weightage of this chapter, remember, because this chapter is very small and the weightage is very high. So easily we can get the 7 marks. 7 out of 7. How to get 7 out of 7? I will give the hints. So more 6 minutes are remaining. So again I am going to mute all and I will just start the introduction of the chapter, that is coordination compounds. The screen is visible? Yes, anyone tell me?
Yes. Yes, sir.
So this chapter is for 7 marks, remember. It is having a weightage increase. I have increased the weightage of this chapter purposefully, remember. It is last year's weightage was only 4 marks. So I have given the weightage for 7 marks here. Till I think officially the weightage is not declared by HSC board now till. but within 2-3 days the HSC board will declare the weightage. So the weightage will be same. Don't worry about the weightage. Yes, any problem? So this chapter is for 7 marks with option, and without option is for 5 marks. So I will just start the introduction part of this chapter. These are some questions as for previous board exams. After completion of the chapter, please solve all these questions so we will understand what type of questions are asked for board exam. Also, today's exercise for you, you have to solve the questions which are given for the chapter amines. In amines chapter also I have given yes, we will start the introduction. What is meant by this coordination chemistry? So what is this coordination chemistry? See, it is a branch of chemistry which deals with the study of complexes or coordination compounds. Coordination compounds are also called as complex compounds. This is a branch of chemistry like organic chemistry, physical chemistry, inorganic chemistry. This is also the branch of chemistry. It deals with the formation of coordination compounds. And these coordination compounds, these are widely distributed in nature also, in minerals, plants, animals, and they play very important biological function. So I will just show how the coordination compound looks. See, you know the word chlorophyll, which is important for the preparation of food for the plants. So how the chlorophyll looks? This chlorophyll is a coordination compound of this magnesium. Magnesium is the central metal atom. Every coordination compound having the central metal and which is bonded to the ligands. This is called as ligands. So these structures are not as for the exams. This for understanding purpose. I have shown these figures. This is a chlorophyll. It's a coordination compound. Means how the coordination compound looks. For this purpose, I have shown this slide. Every coordination compounds having the central metal atom. See, this is a coordination compound. Name is hemoglobin. See, this is a coordination compound of iron. Hemoglobin is a red pigment in blood coordination in blood. So this is a coordination compound of iron. See here, Fe is a central metal atom, and these 4 nitrogens, these are bonded to the central metal atom. These are called as ligands. So these are the 2 examples purposefully I have shown at the introduction, because you should know, you should have the idea how the coordination compound looks. So coordination compound is a very large compound which is having the central metal atom, and it is surrounded with ligands. The ligands are nothing but they donates their electron pairs to the central metal atom. So one by one we will discuss all these things. I think this much is sufficient, because many students are now, these are absent. So tomorrow, day after tomorrow, we will start this chapter. So I'm going to end this lecture now. Have a nice day. Prepare your homework.